Hi, my name is Caroline, and I work as a product manager at ESSVE. At ESSVE, our Swedish heritage is at the core of what we do. Since the very beginning, we've worked with craftsmen, installers, and builders, listening to their challenges and creating fastening products that make their work life easier. Today, we offer a complete range of fastening solutions, 5,000 products, which are used on building sites all across Europe. Experienced engineers who support you. Challenges, experience. I'm interested by all the way to solution. Start the process. Engineers and experts know that specifying the right cost there can be challenging. What's the simple, reliable tools that make it easier for engineers to choose the optimal products for the design? There is a no-brainer for us.
So welcome everyone. Let's start. It's 10 o'clock. We are in Eastern time starting academy. And we having today's subject spec toolbox. And if you have in end also time, we like to introduce a little bit on a handbook with calculation samples. And what we can say is that the agenda is for introduction, 5 minutes. Then we have that case study which supported by spec toolbox. And then we have in the end also answer some questions. Who don't know about this, then we can say that we are a nationwide distribution in Nordic retail areas. We are founded in 1970. Of course, we are in fastening business, which supported around 200 employees. 7 countries we are existing here in around Baltic states and Nordic area. We belong to Bergman Gaming Group, and a fun fact is that we're selling 5 million ESSVE screws every day. About our areas where we are able to supply your services are structure and foundation, building envelope, interior finishing, and also structure carpentry area. The academies we run at the moment is mostly related to timber. So today's subject is timber and glulam, and the tool which helps you to do the daily business. So I still remind you that we have also ESSVE own tool named ESSVE. If you don't know about it, feel free to ask me, support, or Radek or Tia. But as today's subject is mostly spec toolbox, then I like to introduce our structural engineers. From ESSVE side is Tia Jamil and Victor Bukovsky. They are either one technical expert or a product manager. And like to also introduce Marko Dmitrievich, who is a spec toolbox product manager. Now, before I would like to give hand over to Marko. Are you there, Marko, in overall?
Yes, I'm here.
Oh,
thank you.
Before you start, I will look, can I also release a poll? And the first poll, what I like to ask from the participants who are taking part of that academy today is, how much do you know about Spec Toolbox? And as we introduced that previous March academy, then I'll let you to give us a feedback here that do you heard that in first time? Have you already used it or are you really doing calculations there, or you just love it and already working in it? So give us a feedback. What is your choice? And we will, you can see it on the chat field probably with the result as well. So at the moment, 27% heard that first time, 55 is have heard but not use it, and 18% is have done also some calculations already in it. So anyway, this is the feedback what we have it, and now Marko, I will give the hand over to you.
Thank you so much. Hello everyone, really nice to see you again. For ones that are first time hearing about us, so I'm Marko, I'm product manager at Spec Toolbox, and I'll take you through some of the information about who are we and also how you can use Spec Toolbox in some regular design situations. So I'll share my screen at the beginning. And so from the start, we'll talk about how you can use ESSVE screws and utilizing them within some specific design situations. We're gonna show you also how to sign up at Spec Toolbox, some of the upcoming updates. Then we'll talk about some information about connection design, and then we'll take you through beam compression perpendicular to the grain design. We're using ESSVE screws for screw reinforcement. At the beginning, I would like to point out that you can use this link to go and sign up at the platform. And also, if you reach out, you can get the 60 days of all the pro features and a full extension on the app. Also, just to point out that using ESSVE screws is totally free, and you can do that in the free version with all the design scenarios and examples that we have and that we'll show. In terms of the differences, so mostly you can do with the free version, but if you like to just try a pro version, as well as in the enterprise where you can collaborate with each other, feel free to reach out to us or with the ESSVE team so we can provide you with the trial. In terms of some of the upcoming updates, I'll briefly mention about something that we're working and will be available in the coming weeks. So we're working on a panel connection. So as you know, there is a lot of usage of these type of connections between panels, so half lap, spline, and butt joint. So we already have the version of this calculation, but we're working on a new version with new improved workflow and possibilities for the design. So that's something that is coming very soon. Also, in terms of the new UI and the updates that we're preparing, so just a preview of how the new double bolt module would look like, but also this is something that will apply a template to all other calculations. So we are working on having improved our user interface and how calculations are working in general. Also, in terms of the fire calculation, so for ones that are also interested in member calculation, we're working on joining non-fire and fire design, so that will be part of the single calculation that includes CLT floors and walls, and also timber beam and column calculations. Also, everything is working now and updated on latest Eurocode 5 from 2025 version. Also, interestingly, we are updating CLT shear wall. So this is also something that can be interesting to use, and especially with the new updates, including bracket hold downs and multiple floor level calculations. Before we start, I'm just briefly going to take you through and show you how some of these updates already looks like. So as I mentioned, this is not something that is available, but if you jump on the app in the next few weeks, you'll also be able to see this as well. So this is an example of half lap joint. Now working with the dynamic 3D image. I have Sodro as a manufacturer from the panels. There is also a lot of options for modification of the half of the lap, of the loads in direction perpendicular to direction of the connection. Also, a new Eurocode from 2025 is available, but most interestingly, you can select SSVE screws together with their ETA integrated in here. So this is something that works simultaneously, and you have ability to see the performance of the design in this calculator. Going further, I'm going to briefly mention about some of the connection design and using screws in general. So we talk about the last presentation about some of the benefits for examples. I just want to point out some of the around find by head pull through screw steel property and yield bending moments, and we'll see how some of these properties are being utilized in our example very soon. Also, in terms of the screw properties, for so we have 3 classes depending on
Is it me or is it only Marko? You? I'm just interrupting you. That we have little lag on a connection. Is that only me, or is it someone else also having that problem?
Marko is lagging.
It's lagging a lot.
Yeah.
I'm sorry. Can you hear me now?
Yeah. Can you? I hear you now, Marko. But you were going in and out quite much. So it was difficult to follow you, actually.
Yeah, I apologize. I'll just go back from one slide. So as I mentioned about the timber screw properties, so we have typical environmental conditions and service classes depending on it. Also, the situation where those situation can be selected. Going further, we also have corrosion classes, so C classes according to ISO standard, and T classes according to EN standard. That is something that are also important factors for the design. So more C classes are measures the aggressiveness of surrounding environment, while T classes evaluates the corrosion potential of the timber itself from T1 to T5. Going further with our design examples, we're gonna show about how you can utilize the ESSVE screws fasteners for situation where you have a glue lamp compression perpendicular to the grain at the support. So we're gonna look at our design example from the last time, and we're just gonna look in the roof elements, typically for columns and beams, and we're gonna use that for the example where we can design and support beam with the maximum factorized reaction force. We're going to check first without reinforcement, and for reinforcement, we're going to use ESSVE fasteners. Before we start and jump to the app, I'll just quickly will explain something about design standards around this calculation, especially because we have a current standard in Eurocode, also a draft new Eurocode from 2023, and also we're working on the 2025 version implementation. So just to point out to some of the differences, because in this typical calculation, there are many of them. So the first one applies for typical or current Eurocode verification, where it's only relying on KC19 factor that is typically 175 for glue lamp. While in draft code and in the new Eurocode, that's something that is being calculated differently. And beside this factor, there's also KMAT factor that should be included. So something that is also included, not just factor for the stress spreading, but also factor accounting the material behavior of the compression perpendicular to the grain. Furthermore, this is just a preview of explanation of KMAT and how we're going to use and apply that to the calculation we have. So for both draft and the new Eurocode, it's defined with this table, and also you can see some notes and values when it's how this factor can be applied. And also in terms of the reinforcement, some of the differences and preview of between the draft and the new Eurocode and the current Eurocode. This is something that was lacking and was not part of it. So we're gonna focus on this calculation, and especially pointing out that some of these factors, as KMAT, is different when we have reinforcement and when we don't. So that being said, I'm gonna go back to the app and we'll try to design this situation by ourselves. So you can see here we are in the GLT compression perpendicular to the grain calculator on our platform. For our data, I selected GL28H class. We have a cross section of 240 by 520. We can also see some of the options where we can have a supporting column dimension. So we selected 200 by 200, and we don't have any offset. We're going to start with Eurocode 5 from basis of 2004, and without reinforcement. For loading, we have over 110 kilonewtons. We have end support, and we're going to calculate KC19 by the code. And so we have service class 1, long-term actions, gamma, and cases as default. In this case, we can see just a preview of compression without reinforcement. It's at a bit more than 100%. We can also see the details about the material properties and how this is being calculated. So not too big calculation and not too complex, but that being said, I'm just going to switch this to the new Eurocode or the drafted version, and we're going to see some of the things here being designed. So for instance, what we have changed here is we have some additional inputs. So as I mentioned, beside the regular coefficients, we also have KMAT. For this case, we're going to adopt 1.4 as the most used or suggested value. In this case, we can see the compression is a bit higher. So we have 10% or a bit more 10% difference between the new or the current version of Eurocode. And we'll try to solve this with adding reinforcement. So if we select yes in this case, we'll have additional inputs where we have option for screw depth, screw geometry. By clicking on this, we can select as for screws. And in this particular case, we have option for a whole suite of their products. So in this case, we're going to take some of the appropriate ones. So we're going to take a cylindrical fully threaded zinc plate screws. So in this case, we can select the exact diameter and length. So we're going to start, for instance, from 8 times 260. Also, there is additional inputs for we should input here is YK. So we know this according to their properties that it's 950. But that's something that's also linked in the more information and the properties of the screws that we're using. And also what we have option is also to select numbers of screws in the direction in perpendicular to the direction of the support. So we can start from 1 screw and we can set 2 screws in the other direction. And we can also set this to the middle of our support. So in this case, I'll try to set this in the middle. So we have 200 wide column. So I set it on 100. And also, if we look the other direction, we can see that these location are practically on the distance of 80 millimeters. Going further, we also have a different KMAT in this case. So it's 1.75 according to what we stated in Eurocode. So I'll just quickly go back to that and show you how this is suggested. So for the reinforcement, we have for glue lamp products 175 as suggested for KMAT. So that's something that is different than situations where we don't have when we don't have reinforcement. Going further, so if we go now back to our results and calculations, we can see that we have fulfilled the geometry checks and also compression check with reinforcement. We can go now in details and see what are the exact steps and calculations. And also in this case, again, we have information about material properties. We have compression perpendicular to grain according to draft version of the Eurocode. So this is something that we are updating to the latest version, although there are not too many differences, but just wanted to point out the complexity and the differences between the calculations here. So starting from the beginning, we have information about some of the coefficients and how this is being calculated. Then geometry checks, so the position of screws, how they are aligned with the position of the geometry and the calculations we have. And the last part is regarding reinforcement, so how the compression force is being utilized by the properties of the strength of the screw. So here, firstly, we have information about characteristic withdrawal resistance. So we can see how now which formulation and refer to which part of the Eurocode is being used. We can now see also the step-by-step process of this calculation, so properties of the exact fastener, also all the calculations that factors that are needed for calculation. Then going further, we also have characteristic compressive resistance, so that's also part of something that is part of this design. So based on the properties or characteristic yield strength that we inputted at the beginning, we have a verification on that, and practically we are calculating the ideal elastic buckling load. And the last part is characteristic yield capacity of the fasteners. So that is part of compressive resistance at the end, and load carrying capacity of reinforcement concrete area.
Excuse me? Someone is having a loudspeaker on. I try to manage that.
No problem.
Yeah, go ahead.
So we have load carrying capacity of reinforcement concrete area. So basically how all of these factors are being used and what is the capacity of reinforcement area at the end. So we can see some of the factors that are being used here. What is the width of the contact area, properties again of or cross section of our member, and in the end we have information about threaded part and load carrying capacity of our screws. So in the end, you can see compression perpendicular to grain with reinforcement, or what are the numbers in between of this. So we have design compressive force and we have design load carrying capacity of reinforcement concrete area. So basically how this solution, in this case, 2 screws, fully threaded screws at the middle of the supported area, help us to transfer the force and have this solution in the first place possible. So just wanted to point out some of the differences as firstly with using the new or draft Eurocode, and also some of the information that using this also requires some of the information of new factors that should be checked in details in code, and have differences between reinforced and non-reinforced cases. So in this case, how this looks and how it can be utilized and designed. At the end, what we can do here is we can save the calculation. That's something that can be available within our project level anytime we want to go back and see or change something. And also we can have printout reports. In this case, we have a full report available. We are also working on the shorter version. But once this is being generated, we can use this PDF report to share or use it in our design documentation according to that. So I'm just going to open this quickly. So everything that we have is in design is also presented here. So information about which screws, which dimension of them, which analytical method or standard we've been used, also information about utilization, and then in details all the checks and calculation steps for this design in particular. So how reinforcement helped us here in this case, and how we can use these screws for this design situation. So that was shortly from our side. Again, big thanks to ESSVE team and NFBR and Victor, and thank you all for your time here. So I'll leave some time for questions and any comments. Thank you.
Thank you, Marko. Yeah, audience, I don't see in the chat field any questions, but as the first poll request side gave us that 18% have used it, this, are you having any questions, gentlemen, ladies and gentlemen? Or Victor and Tia, you wanted to ask something from Marko?
No, I don't have any.
No, it's not any question from my side either.
So maybe I will release just another poll then. Maybe somebody thinking to pick up the question, but the next poll will ask that what application area you use the most. You can give us here also multiple answers. So it's give us an overview that where to develop the most and to see also which way your daily life is moving in our audience side. That is it you more in average timber application area, or some of them are specified or strong on CLT or glue lam areas, or some other ones, prefab framework or hybrid applications. So feel free to give us the feedback. Everybody can find answers on the chat field. But looking in chat, send please the link of the check. How is it work? We have it a question from Armand.
Yeah, thanks. I can share the link in the chat, how you can register and sign up, and also how you can check this calculation by yourself. But we will also be sending the presentation and the output report of this calculation after, so you can also check that as well.
Mm-hmm. All right, super. The link will come here as well soon. As I promised that I will show a little bit about the handbook, and I will say some words and share the screen. We have passed now 13 academy sessions, and on the beginning we had a request that could you put the session together in some kind of book, and we have been getting to the stage where the book is finalized, but not yet available in ESSVE website. And the book cover page looks something like this. If we go through the book to the page number 5, where is the content, then the content having active links here. So when you receive the booklet, and I try to share it on chat field, in end, then you can download it there. Otherwise it's 26 mega and probably not going through by email, but you will find here different connections, and the first part is an Excel loaded area, and that is who is willing to do the manual calculations. And let's say we had a subject here, let's say CLT wall connection, and we can go on page 20, for example. Then you can look at how the calculation is made. You see the application input description, the way how to calculate it, and you will get it in end fulfillment verification percentage. We can do a quick another, let's say jump, I go back in page 5, and let's say we pick up something from the end in a lateral side. Let's say we're gonna have here thermal insulation, for example. Why I'm talking about the thermal insulation is because this application you can calculate for roof or wall facade application. And we're planning to have it in May 7th, academy session about it, 20 minutes to introduce how to calculate and what software ESSVE have to offer you. And here is a manual way how to calculate it, the guidance and the verification. So it is just such a samples are in it. And if you go forward, for example, here, you will find also main and secondary beam, which was our session from Eero Tuhkanen in Taltech in November. And he made a comparison on screw connection compared to joist hanger connection. And if you go to the calculation end, then there you will find it, the verification and comparison to the joist hanger with the verification and installation time. So here we saw that with partial nailing was 141%, but full nailing was okay. If you go forward, you will see also some comparison application, what you can do all with screws. So here is a sample of strengthening a beam or doing a horizontal or rafter strengthening with bolts or screws. We can also do different connections with screws or bolts, comparison and installation time samples on the bottom. So the idea for that is to more advertise screw connections and to bring out also from the installer side that it's actually faster to do it. So feel free to test and use our calculation tools and find the samples. And in the end, it's an area of edge and end distances. And here is info in it. How is it? Where is it? How many millimeters? How many Ds? So you will find axial connection, you will find lateral connection, edge and end distances, and you will find also the edge and end distances for CLT wall elements in wide end and in the narrow end. So that's a short introduction of this booklet. I will look what can I tell you more because the time is over. And if I go here for next slide, then this next slide is introducing you to having next academy session in 7th of May, and we will send you invitation. Then here I will try to copy this PDF file. Do I get it copy? No, I don't get it. Then I have to find a way how I can copy that in a chat field, that file. But I will work that out. What else can I say for ending that your local closest support in Eastern Europe is Radoslav. He is our technical expert located in Poland. Product manager is of course Victor, and we are happy to have you here in the board as well today and the academy. And then me on the sales side. If you're looking for demo on ESSVE, then I can support you that. But if you're looking local demo of Spec Toolbox, then we have a DR. And DR is the first step to help you on that in the future. So from my side, I'm quite in end. If anyone have still a question, go ahead and ask. Otherwise, I will release the last poll to get the feedback, how happy you were with Spec Toolbox availability in your daily life. And did you learn something? Do you look at positive doors to future? Go ahead and test it. I'm very happy about and proud about the cooperation with Spec Toolbox. So feel free to give us the feedback, and thank you very much. From here, I will stop the recording, but you are free